Okay, so we're writing equations from a given table. So we here have a time and temperature table. And we're going to write an equation from it. So they have used H and F. We could use X and Y. Our X would be up here and Y would be down here. We want to remember our equation for a line is Y equals mx plus b. M is our rate of change. B is our y-intercept. So we can call that M is slope or rate of change. B is y-intercept or where our line could start. And so we're going to find our slope. It's the change in y over the change in x. So I'm looking at my y side of the table right now, and from 82 to 80, it's negative 2. From 80 to 78 is negative 2. And as I go down here, each time I'm subtracting 2. Looking at my x column, every time I go to the next number, I'm adding 1. So to write my slope, the change in y over the change in x, that would be negative 2 over positive 1. Now I know that when a number is over 1, I don't actually have to write that. So to write my whole equation, I would do y equals negative 2x, and my y-intercept is 82. I know that. I know the y-intercept is 82 because wherever my x number is 0, that number next to the x is my y-intercept. Because if you think about it on a graph, the y-intercept crosses the y-axis, and then you haven't gone side to side on the x-axis at all, so x is 0. So my slope was negative 2, and my y-intercept was 82. Okay, here's another table, and this time they've actually used x and y for us. So the first thing we're going to do, write our equation here, our formula. This is the formula, y equals mx plus b, and then I'm going to find the change in the y column. So from 15 to 11 is minus 4, and from 11 to 7 is minus 4. Then from 7 to 3 is minus 4. So I have that constant change. It's going the same exact amount every single time. And then on my x, negative 2 to negative 1, I'm adding 1. From 0 to 1 is 1, and so on. So my change in y is negative 4, and my change in x is positive 1. And I know that if I'm over top of a 1, I don't actually have to write the denominator, so I can just put negative 4x for my slope, or for my rate of change. And now my y-intercept, I told you when x is 0, the other number is my y-intercept. My other number is positive 7, so it's plus 7. So that's my whole equation. All right, we got another one. So again, thinking about my slope, my change in the y column, 15 to 10, we got another negative slope. These are changing by 5 every time, negative 5. And then my x-axis is changing by positive 1 each time again. So that gives me negative 5 over 1, which will just be negative 5. My y-intercept is not actually on this table because I don't see 0. I have to work the table. I have to add 0 to the table. So now I'm going backwards. So from 1 to 0, I'm just, taking away 1. So when I go backwards, instead of subtracting 5, I'm going to add 5. So I would get 20. So that makes my y-intercept 20. So I get negative 5x plus 20. All right, now this one's got the table set upright. I prefer this, but I know you guys will see the laid down kind. Again, change in y. Here I'm adding 6 each time. And on the x column, I'm adding 2 every time. That little triangle just means change. It's a science symbol. So 6 over 2. Now, I can reduce that. 6 divided by 2 is 3. So my rate of change is actually just 3. But again, my y-intercept is not on this table, so I need to work backwards. Go back 2 to 0 in the x column, and then go back 6 in the y column. So 10 minus 6 will give me 4. So here my equation will be my y-intercept is 4, and it's positive, so it'll be 3x plus 4. All right, so now we have figure out the missing value for Professor Bottano's table. So I have the number of the days since the seeds were planted and the height of the plant in inches. So I'm figuring out the changes I can already see. From 8 to 11 was plus 3, and from 11 to 14 is plus 3. So I can use that pattern to fill out the rest of the table. So going backwards, 8 minus 3 would give me 5. And then I would do 5 minus 3 to fill in that first box, which will be 2. If I want to fill in past the 14, see when I go all one direction, it's all adding 3. At the top, I'm adding 1. So I can figure out the rate of change here. Every day, for every 1 day, the plant grows 3 inches. And then to fill out my table, notice that they were skip counting all of a sudden. We were counting by ones, but then they go from 4 to 6. So they skip. So we add in 5 and 17 and then 20. And then if I'm jumping from 6 to 10, there's a couple ways to look at that. But first, the plant's daily growth rate is 3. And the initial height there on day 0 was 2. That's our initial, remember, is start. That's y-intercept. So they planted this seedling when it had already grown a little bit. So our equation here is y equals 3x plus 2. And that is it.